Scientists divide the atmosphere into a number of layers. The primary regions are defined by how temperature varies with altitude. At the bottom is the troposphere. Its height varies with latitude and over the seasonal cycle, but it is on average about 12 kilometers in height. Since the lower atmosphere is warmed primarily by long-wave radiation from the ground below, the troposphere has an inverted temperature profile, warmest at the bottom and cooling with altitude. This layering, with warmer air below cooler air, causes vertical mixing via convection, and it is this mixing that creates weather. At the top of the troposphere is the tropopause. The tropopause is a transition region where there is very little change in temperature with increasing altitude. It is found about 10 to 17 kilometers above the surface of the Earth. As with the troposphere, its height varies with latitude, over the seasonal cycle, and even in response to local weather events such as thunderstorms. The top of the tropopause is marked by a temperature inversion where cooler air sits below warmer air. This region is the stratosphere. It extends from the top of the troposphere at about 12 to 17 kilometers up to roughly 50 kilometers. This stratified temperature profile with warmer air above cooler air creates a stable structure with very little vertical mixing. The stratosphere contains the ozone layer, which is a region of the atmosphere from about 20 to 40 kilometers that contains the majority of ozone in the atmosphere. This region is important for life on Earth because it absorbs harmful ultraviolet radiation from the sun, preventing it from reaching the Earth's surface. It is the absorption of energy in this layer by oxygen and ozone that causes the warming with increased altitude observed in this region. On top of the stratosphere is the mesosphere. It extends to about 80 kilometers. Like the other layers, it is characterized by its temperature profile. In the mesosphere, temperatures fall with increasing altitude, reaching the coldest values of around negative 85 degrees C at the top. Air pressure in this region is less than 1/1000th of that at the surface, and it is this lack of gas molecules available to absorb incoming electromagnetic energy and the radiation of energy to space by the molecules that are present that cause this region to be so cold. At the top of the mesosphere is the mesopause. Like the tropopause, this is another region where temperature does not change with altitude. The second to last layer of the atmosphere is the thermosphere. It is a region where temperature begins to increase with increasing altitude again, although there is so little air here that the high internal kinetic energy of the gas molecules, that is, the high temperature, does not add up to much in the way of total heat. The thermosphere includes the Kármán line at 100 kilometers, which is considered the edge of outer space, as it is the point where air is too thin to allow aeronautical flight. The thermosphere extends beyond the Kármán line to an altitude of 500 to 1,000 kilometers, depending upon the amount of solar activity occurring at any given time. The outermost layer of the atmosphere is the exosphere. It extends from the top of the thermosphere at around 1,000 kilometers to 10,000 kilometers. The molecules in this region are few and far between, and they include mostly low-mass molecules such as hydrogen and helium. These molecules are considered part of the atmosphere because they are gravitationally bound to the planet, but they are so sparse that they do not act like a gas. Atmospheric density decreases exponentially with altitude. Half of the molecules in the atmosphere occur within the first 5.6 kilometers, and the density drops quickly from there. 3/4 of the molecules are within the first 11 kilometers, and 90% of all the gas in the atmosphere is within the troposphere and the tropopause. Over 99% is within the first 100 kilometers. Even with this concentration of gas near the surface, there is no clear boundary between the outer layers of the atmosphere, with most of the molecules in the exosphere being considered as part of the outer atmosphere due to the fact that they are orbitally locked to the planet.